Next property we are going to be looking at is loudness. Loudness is the most obvious property of a sound. Whenever we talk about sound, we normally associate it with how loud or how soft it is. So it relates to the human perception. We'll come to the Weber-Fechner law, but generally loudness is it is proportional. 1 minute. Yeah, so coming back, loudness is a property of sound which relates to how intense it is. Again, like I said, pitch is not equal to frequency, but it is sort of an indicator of frequency. So the higher the frequency, the higher the pitch. Similarly, loudness is not equal to intensity, but it is an indicator of intensity. So the more intense your sound, the louder it will be. And what is the relation between intensity and loudness? So now loudness is also called intensity level. So there's a difference between intensity and intensity level. So intensity level is the same as loudness, and the formula is log of I by I naught bells or 10 log I by I naught decibels. So bells and decibels are the units used. What are I and I naught? I is the intensity of the sound you're talking about. So I have a sound source, I'm telling you its intensity is so much watts per meter square, and I'm asking you to find its loudness. Then that intensity is what is represented by I, and I naught represents the threshold intensity of sound. What is the threshold intensity? It is the minimum intensity at which a sound is audible to you. So even if a sound lies within the 20 Hz to 20 kHz range, if it is below this intensity, it will not be audible. And that's obvious, right? There is a minimum volume level at which you begin to hear. So if someone's speaking at a volume less than that, you cannot hear them. So that minimum level, it is again a loudness level, and corresponding to that loudness we have an intensity. That is what we call the threshold intensity, and that is generally 10 to the power minus 12 watts per meter square. Now this threshold intensity can change depending upon your age and upon how much you use your headphones, kind of stuff. It changes, but on average we assume it is 10 raised to minus 12. So now loudness is equal to log of I by I naught is equal to 10 log I by I naught decibels. And if a sound is described in terms of pressure instead of intensity, then loudness is 20 log P by P naught. And P naught again is the minimum pressure at which we are able to hear a sound wave, and that is 2 into 10 raised to minus 5 pascals. So any questions in this? Okay, so now we come back to the Weber-Fechner law. So this law, we are studying it under acoustics and in relation to sound loudness, but it is equally applicable to any stimulus which you perceive through your sense organs. So it can be brightness, it can be temperature, it can be sound, anything. So what it says is the change in perception is directly proportional to the change in stimulus and inversely proportional to the stimulus itself. Meaning, you have a stimulus which is sending you some signals. It could be a sound wave or a light wave, or there is some stimulus and it is sending you signals in the form of a wave. So when there is some change in the stimulus, your perception also changes. Meaning, I have an object, I am looking at it. Now suddenly the brightness of the object increases. For example, it's a movie screen, let's say, and a night scene was going on. Now it shifts to a daytime scene, then the brightness increases, meaning my perception also immediately changes. My eyes, they get adjusted from the darkness I was previously viewing to the light immediately. So once my stimulus changes, my perception also immediately changes. So that is what we mean by change in perception is directly proportional to change in stimulus, and it is inversely proportional to the stimulus itself. This was experimentally determined. So del P is directly proportional to del S by S. So to remove that proportion, you add a constant. So del P equals K del S by S. When you integrate on both sides, P equals K natural log of S plus C. This is the equation you get. Now this is some constant of integration. It was experimentally determined that this constant is equal to minus K natural log of S naught. Now what is S naught? S naught is the threshold of stimulus, meaning the minimum level of that stimulus at which you can perceive. again, like the minimum loudness of sound, or the minimum intensity at which a sound is audible to you, or the minimum brightness at which you are able to clearly see an object, that the minimum level of whatever stimulus it is that is required for you to be able to perceive. So what do we get? P equals k natural log of s minus k natural log of s naught, which is P equals k times natural log of s minus natural log of s naught, which is k times natural log of s by s naught. This is because log of something minus log of something else becomes log of a by b. So, and to make this to a natural log into log to the base 10, we make it k into 2.303 log s by s naught. So that's how we get the derivation. So what this Weber-Fechner law is essentially trying to tell us is when the properties of your stimulus change, properties meaning brightness, loudness, strength of the stimulus as such, when those change, your perception also changes immediately. It is directly proportional. And finally what they're trying to say is P is k into 2.303 times log of the change in stimulus. So that is what essentially the Weber-Fechner law says.